in case of perceptron rule, you start with the initialization of the weights and the bias. You can make it equal to 0. Okay, and then we need a threshold value that is defined as the notation for that threshold value is given as theta. Okay, right. So now you see, you can actually initialize with certain amount of learning rate, right? We try to keep it normally between 0. Okay, then you see, as I told, the bias value b plus summation of input xi into the weights wi for all the possible values of I. Right. Now you see, once you have this value, you calculate the output of a neuron defined in the following fashion. Right. If you were the z value, which is the partial output, is right greater than the theta, output is restricted to 1. Okay, and if it is between minus theta to plus theta, you can keep it as 0, and lesser than minus theta, you keep it as minus 1. So the transfer function is like this, which we can see in the plot. So minus theta to theta is 0, greater than theta it is plus 1, which is over here, and lesser than minus theta it will be minus 1. Right. Now, right, using this I compare the final output y with the target. Okay, if at all you see that the target being not equal to the current output, or output not equal to this, and the input is non-zero, right, you will try to update your weights as well as the bias. Okay, so the weight updated using this equation, next weight, that is wi plus 1 is equal to wi plus alpha times t into x. Right, then the next value of the bias, that is bi plus 1 is equal to bi plus alpha times t. Okay, so x is 0. If at all your current input is 0, you don't update, because that's what is the condition written over here, right? It says that xi is not equal to 0. So xi is 0 means don't update, right? So using this, we keep on iterating until your y and the target becomes equal to for all the given sets of inputs. This is the manual calculation. Definitely we can write a code for that. Okay, so I think we also had solved a problem over here, just right to get adjusted to the procedure, right? So uh, say x1 x2 two inputs, t is the target, which is the output, right? As per the steps given earlier, we simply try to initialize weights as 0, bias as 0, alpha as 1, threshold as 0. Okay, right, so you can see that we perform the epochs by giving all the 4 inputs one by one. Once you complete input 1, 2, 3, 4, first epoch is over. Right, so give the input as this, and the target is 1. Calculate. So you see that you get a z equal to 0, right? Y is sigma z according to this sigma rule. We write the output, and output is equal to 0, which is not equal to the target. So definitely you need to update. Right? So wi plus 1 is calculated as past value of the weight and the learning rate alpha into target into xi. Apply that for both the weights w1, w2, right? You can see that initialized with some value 0, 0, but now you see it becomes 1, 1. Bias also becomes 1, 1, right? Change your input to the next one. So repeat this, right? You can see that z comes 1, the y becomes equal to 1. Again, it is not equal to target because we are expecting minus 1. Update. Take next input, calculate a z, calculate a y, right? Again, it is not equal, update. So fourth input comes into picture. Again, I see that, right? Right? We are able to see this, right? So at the end, we can see that y becomes equal to the target. So no update. We assume that, we'll think that, okay, we got some values of weight and biases. Let us check whether this classifies our problem, right? It's a simple AND gate, so it's a linear classifier. Let's expect that it gets solved. What we do, we calculate a straight line equation using the weights and the biases. correct? So substitute the weights and biases to this equation, right? Which is whatever is written inside the red colored rectangle is the standard equation. You can substitute over there. You get an equation x2 is minus 1 minus x1 plus 1. So the plot will be this blue line, which actually separates the two classes. In case of a AND gate, minus 1 1 minus 1 minus 1 minus 1 and 1 all under the under one of the class, and 1 1 is the other class. Your straight line separates the classes. All right, so like that, that's what is the case. Okay, again, we had solved a few more things over there, but let's come back to the MATLAB code, which is the implementation part. Okay, so we had started with something. Let's look at that. So our intention is now to classify a four different classes using a multi-layered perceptron, right? So in the previous program, we saw how to classify a two-class problem, right? There were two classes, and we could understand. We could also uh, plot and visualize the designed neural network, right? Which could classify our two class problems effectively, right? But now, what we are trying to do here is that we have four different classes, right? And all the four classes we want to separate. We want, again, this is a non-linear problem, so definitely a simple neuron for a multi-class is not applicable over here. So we are using what is called as a ML, that is a multi-layered P for perceptron. Okay, again, the steps which we mentioned over there, right? All the steps which we mentioned over here. So these steps, so all these step number 1, 2, 3, 4, 5, whatever we saw, right? MATLAB has its built-in, right, which can perform all these work by itself. Okay, so anyway, the manual programming is also possible, which we had already seen in the fundamental classes. Now we are moving towards the advanced level, so wherein we are trying to, we don't want to waste time writing the fundamental codes. We simply can use the built-in functions to implement the same. Okay, so all the steps mentioned earlier will be taken care by the MATLAB commands itself, built-in commands. All right. Okay, let's move further. Now let us see what we had done. So initially, I'll just run this part. Okay, so let's go to run and advance. It will clear everything. Then we created the classes. Okay, so in each class, we need 1000 samples. 0.6 is a class offset, right? So between each class, we want a separation of this much. So how many samples are created? If you remember, each class has two rows, 1000 samples. So altogether, you can have how many samples? 4000 samples, two rows, right? So again, we plotted that. So when I run this, I should be able to see the plot. Okay, right? So the plot comes up. We also had given different colors so that we can visualize them properly. Okay, right. So after this, now let's move further. We also had in the next section, sorry, in the next section, though we had 4000 data points, we didn't, the simple creation of the data point is not enough. It's not, it cannot be considered as a data set. For that, you need to write, properly define what are the inputs and what are the outputs, right? So for each of the class, we call a target, right? So since you have four different what you call classes, we define four different targets, right? So each class has only one plus one, right? All others are minus one. Okay, since we are using perceptron, I am very sure that why we are writing minus one and plus one, why not zeros? Because perceptron's output is plus one or minus one, depending upon, right? Uh, the values, right? Whatever you can get in the output values, it should be zeros or not zeros, minus one and plus one, right? So you have the targets defined accordingly. Four classes. Okay, then we define the inputs. Already the class A, class B, class C, and class D. data points are defined, you try to concatenate them inside a matrix to get a 4000 sorry 2 rows into 4000 columns data input. Okay, so then we have a target also should match to the number of columns in the input, so you have to have one row 4000 columns, or not one row in this case because there are 4 rows, right? This is a dash, so it is a vertical matrix, right? So it's a column matrix, so that means you have to have, right, 4 rows 4000 columns. Okay, so let's run this. So that input and the target is going to appear over here in the workspace. Okay, let's run this. So you can see that, right, we got the input, which is here, that is a 2 rows into 4000 columns, and I also have the target defined, which is 4 rows into 4000. You can see the size over here, right? So 4 into 4000, and the input is 2 into 4000. Okay, then let's move further. We defined our network. In order to define a network, I can use a feed forward network, because everything that moves from one side will keep on moving towards the right, which is output. So you are simply feeding the data and the partial results you obtained to the next layer. So it's a feed forward layer. That's why, okay, this is the command, built-in command you can use, right? Then the size is defined, right? You can vary the size and see the performance later. So everything I want to use it for a training, so this is, everything is training, right? You can definitely go for validation, testing, etc., right? So reduce 1, you can make it 0.8, 0.1, 0.1 if you want, or 0.7, 0.2, 0.1. So the sum of these three numbers should be equal to 1. That's all. Okay, it's the ratio. That's why highest number is 1. Okay, then, right, create your neural network. That's by name my ANN, and pass that my ANN with the corresponding inputs and the targets you defined to train. So train is a inbuilt command to do that job. Okay, this provides the ANN, the Y, which is the output when during the training, and the error it observes. Okay, so now let's train this and let's proceed. So once the training gets over, I should get a variable called my ANN in the workspace over here. Okay, let's run this and advance. It's going to take some time, right? Because I have 4000 points, and you can see, yeah, my ANN is appearing here. So that means, right, the training is over. Let's go for a testing part. Directly we can go ahead and do the testing here, right? You see the small logic has been applied here, because I have the Y which is here. This Y I want to compare with the original Y. Original Y is this target. Okay, I just want to compare both of them, right? So whatever is the target, compare that with the Y. So you see maximum of the target that comes into I, and this comes into J. Okay, so length of Y is calculated. Initially I use a variable k equal to 0. This holds the number of correct classifications. Okay, right. Now, so find of I minus j is actually the point by point subtraction between vector I and vector j. Okay, wherever both are equal, right, I and j, one is the target, one is the machine's output. You see, there is an error if target minus y minus target is non-zero, means there is an error, correct? So find all the points where I minus j is non-zero, and I'm going to count that. So length of that gives you the count. Out of your, say, 4000 samples, how many samples are misclassified? Okay, length gives you that number we are going to put it into k, right? So k is the error. So if you want to find the accuracy, how do you define the accuracy? Number of correct classifications divided by the total number of, right, testing, right? So error is k, so total minus error means it is the correct number of correct classifications. So you see here I am calculating n minus k, total number divided by the wrong classification or misclassification divided by n, which is the total number. So that is the accuracy, which comes as a fraction. I multiply by 100 to convert this into the percentage. Okay, so let's run this part to see the output. Now, according to this, right, it classified all the samples perfectly. All right, so till here, I hope no doubts. Okay, now let's do something. Let's try to plot and see what is going to happen. Okay, let's try to plot something. Okay, now the plotting part, let's try to create a new section itself for the plotting part. So I will start with a figure. Let's create a figure and then I'll define a subplot. Say 2 rows, 2 columns, and oh no, sorry, 2 rows, only 1 column. 2, 1, 1. Let me try to plot the targets. Okay. So I think we give a name for our target. Yes. Let me just check the variable names. That's the target itself. Okay. So plot. It will be horizontal. I'll simply try to make it vertical. Okay. And I give a title. Okay, that's targets. Right, I'll turn the I turn the grid on, then 2, 1, 2. The one which is below this. Okay, so 2 rows, 1 column. So second one means it is below the above graph. All right, I'll try to plot the output of the network. I think output of the network is defined as y over here. So I have to plot that. Okay, so plot y. Let's give a title. Response of the MLP. Okay, so this is how then I can just for both of them I can give a X label if required. That's fine. Okay, I'll keep the grid on for this as well. Okay, let's see what we are going to get now. I'll just run this part of the code and let us verify. So there are 4 different colors if you can observe. Correct? Can you see can you see 4 different colors? Right? So 0 to 1000, it's one color. Okay. Then 1000 to 2000, it's actually a different color. The color is yellow, which you can observe on the top because the vertical lines are overlapping. Okay. So 2 colors overlap, so you may get a new color. Right. So the actual color you can see. Okay. I can do one thing. Right. I'll do one thing so that this plot becomes more clear. That I will try to add a y limit. If you remember, if you can specify y limit, right? Do you remember? Limit on the y-axis, right? Because you see, it was the graph which we saw just now is tightly fitted between its minimum and maximum. I'm not, that's why I'm not able to visualize what is the top color exactly. So, but I can specify 2 comma maybe 2 and okay, minimum is to be written first. So -2 to +2. Now you see the y-axis limits of our both. I have to do the same thing over here. Okay. Y limit should be -2 is a minimum and +2 is the maximum. So I want the graph to be plotted with y values between -2 to +2, not 0 to 1. Previously, it was plotting simply 0 to 1. That's why it was not clear. Now you see, right? Okay. Is it okay? Is it clear? Right. So you can see that the graph is actually plotted between -2 to +2. Previously, it was just -1 to +1. Right. So this one is high only between for the samples 0 to 1000. So 1000 to 2000, it's a different uh, activation function or different output that you can see with a different color. Right? Then 2000 to 3000 is completely different color. 3000 to 4000 is completely different. Same thing. This is what it was. This was my target, right? The first waveform is my target. But because of the learning process the machine underwent, you can still, right, make sure that you are getting the same output or the same response by the machine. Is it clear? So it matches, everything matches point by point. You can see that the colors are same for both targets as well as the response of the multilayer perceptron. That makes things very clear that yes, machine has learned something. Okay, fine. So this part is fine. In the next part, I want to visualize what this machine has actually done in classifying this one. So we had something like this, correct? I want to see how the machine developed what you call some of the lines over here, right? To classify this into 4 different classes, because I already have 4 different functions developed by the machine. Just now we saw 4 different colors, right? Will it be able to apply those colors onto these classes to say, yes, okay, this is the color. Because of this color, you can say that this is my classification, right? I just want to try whether I can plot it or not. All right, let's try to do that. So first, I think the basic idea is still coming from our previous case where you can see that we had a span, right? We define a mesh grid, right? You create uh, something like this, right? And you predict the output as output of this. Okay, I think I can copy this because it's pretty much similar to this. I can simply paste it. So let's go for a new section below and let me paste. Okay, I create a span. Okay, I think I don't need a span this much bigger. Let me try to use. Okay, let it be. Let's see. Okay, and if it is not working, I'll change the span value. Okay, so we have P1, P2 as a mesh grid of span comma span. Fine. PPI create, which is the first span and the second span transpose. Simulate your neural network with these values of input. Okay, fine. That's good. So I think we have called a figure 1 earlier somewhere because I want to activate the same figure. That's why. Let me come back. I just have to run this once again later. Okay. I call this as figure 1, right? When I say figure 1, I can actually call the same figure once again because where you want to plot on that graph. Okay, so that's why. Figure 1 calls back the same figure which was there earlier. Okay, so say on the same figure, I want to plot something now. So okay, let's see what we want to figure one. Okay, it's a mesh plot, so can be called by a function mesh. Okay, okay, let's go for a handle first. So m is equal to mesh of the same values p1 p2 we used earlier. So this is p1 comma p2, and let us try to do a reshape function. Reshape of this one, the predicted output, because that is in this order, right? I have it. I want to bring this into the size equal to the span. Okay, so because of that reason, I want to bring it back to the original shape. So I think we have done the same thing over here, if you remember. Of span. Okay, right. So the same thing we are going to do now once again. So this is the predicted output of. So I want to keep the first row and all the columns, comma, uh, length of span, comma. So it's a size should, it's a what you call, it's a, I want to make it a square. So length of span is a number of rows, means I should have length of the span as a number of columns, so that it becomes a perfectly uh, a square. All right. So then I close this and close this. So the mesh is complete. Then go for a hold on. Uh, Plot the second one, because you can see in our predicted output, how many outputs you have? I have four outputs, right? So all the four outputs I want to plot on the graph which is already plotted, that is figure one, isn't it? Okay, let's do that. So once again, I'll use another m now. Okay, I can use the same m, I guess. Let me check. Very sure about this. So mesh of, once again, p1 comma p2. The reshape, perform the reshape, but you see the predicted output I'm going to use, but not the first one. I'm going to do with the second one, because I'm going to plot the second row, all the columns for all the data. So I have to do same length of span, comma, length of the span. Okay, anyway, it's holding on now, so you don't have to call the hold on once again, right? So simply keep plotting. N is also equal to mesh. Okay, for the time being, let me call by different name. If the same name works, we'll see later. Okay, because I don't know whether the same name will work or not. Let me change it. M1, M2, M3 is equal to mesh. Once again, a mesh of the same P1 comma P2. Perform the reshape of the predicted output, but not the second row, now the third row, because there are four rows, right? I'm using like, comma, length of span, that is the comma here, it's going to throw up an error. Length of span. So 3 are over. Let's go for the last one. M4 is equal to the mesh of P1 and P2. Reshape the predictor output 4 comma all the columns in the size, length, span. Okay, I'm not sure what color it's going to generate. If it is going to generate automatically, we are fine. Otherwise, we have to specify. All right. So let's try to run. This is not what we are expecting. So some mistake. We can see a lot of things here. It's a 3D graph. I don't expect a 3D graph. I can do one thing. I can specify it. I don't want a 3D. I want a 2D, right? By using this command. If you remember, you have a command called view. Okay, view of only two, not three, right? So this is possible. Let's see if this is going to generate the required output. Fine. Otherwise, we have to do some modifications. Oh yeah, something comes up, but not colors, right? We were expecting colorful graph, indicating 4 different colors for this. But since I did not mention what color I want, probably I'm not getting the best results here. Okay, let's try to add up the color as well. Maybe that's going to give me some clarity now. So you have to use a set command. Okay, so after you plot M1 or okay, before the set, let me try one thing. Let me try to give our same names throughout. All should be the same mesh. Will that give me a answer? What I'm expecting. I'll just check that. Okay, because set means I have to set for all the 4 meshes which we had created. Let's see what happens to this. Oh, still same, no change. So it means there is no meaning in changing the M value every time, right? All you can do the same thing. So that's what happened now. So even if you change M1, M2, M3, M4, no effect on my graph, right? So anyway, I don't want, I want to keep M as it is, but I have no other option to set, but to set. So you have to set now. So you can specify what variable you want. You see there is a H coming up, which is the mesh name. Already I given mesh name M. In this mesh M, uh, what color you want, because the first mesh is separating only the class 1. Okay, for class 1 you can use a name to the specifier is face name. When I write face name, right, not name, sorry, it's a color, because I don't want to specify any name, it's a color. COLOR in MATLAB. Okay, so face color, you have to specify what space color using R, G, and B. Right? So let's put some value, maybe 1, R for 1, G is say 0.2, and maybe 0.7. I'll put 3 different values. Right now, my intention is to check whether I'm going to get some color or not. Okay, right, I'll close this. Let's see now if this works. Definitely I'll write this something similar to for all other cases. Ah, then is it right what I sent? M face color, that's right. One, maybe I can try with a line folder. That's by using a line. What are the line style I want? And try to specify that. Maybe I don't want anything. Okay, let's Let's try this. Yeah, perfect. Right? So it was not showing the line style, right? Default there is some line style, right? I don't want that. I wanted to get a proper line style like that. That's why line style none is going to, right? You can see first class is this, right? Some color I defined with RGB values. That's the that is closer to the dark pink color or something. Okay, fine. Okay, now this is working. Let's proceed further, right? What I do, I'll try to do the same thing with the this one as well. So set and base color 1, comma 1, comma maybe 0.5 RG. Blue is half. Okay, let's see what color I'm going to get. Let's see. Yeah, actually you can see the color. I think this color is changed, right? So on the right side, uh, that's why that's the new color, right? That's the new color which is okay. So it's working. Let's go to set. Let me try to put maybe 0.4, 1.9. So when we run this, yeah, we can see the third color also coming into picture. Give a last one, and let's try to bring the sample points on those curves later. Okay, because I want to see even the points on that, the various color. Oh, we'll see that later. Okay. We could generate 4 different colors. Okay, now somehow I want to bring back the points. So for that, what I try to do is I'll run from the beginning, maybe. Okay, and I hide my second graph. Somewhere I got a graph here. This figure I'll try to, this part I don't want to plot. Okay, otherwise maybe that will actually overwrite something or it will do something else. That. Okay, let me run this. Let's run and see. It simply converted the graph into the new graph. That's all, right? It didn't. Yeah, points were not. Mm, so let's go back to our first graph and check, can we do something or they can give the same color. Let's try that because that's the only option which is there. Figure 1, plot, grid, hold on, grid on, plot, class B. Okay, okay, let's, but anyway, none of the plot is coming. So everything looks fine. Only thing what I can try to do is to change all colors into the same color. Maybe I don't know whether that is going to be helpful or not, but let us try that once. Okay, so I want to change the colors back to maybe K plus. B star is fine. I can actually make, but color should not matter. Irrespective of the color, it should come. Let's make it KX, BB. Let me simply plot this one. Anyway, that is plotted. Now I'll come to this and maybe this section I can actually reduce and see what's going to happen. Still not. We have -1 to 1. Let me try to reduce this. Maybe the number of points are too much. What we define then what is required. That's why. Okay, possible. That's why I'm trying to change this now. Anyway, I need the first graph, so I'll run this once, this section. That brings up our figure. And on this figure, let's try to run this. Still. Or do the reverse. Let's see. On this, I'll run once again this. Possible? No. This is already a figure 1. Or let's try to do this. Maybe, I'm not very sure. Will it work? I can call a new figure and run it. See. No, it actually plots, but later on it overwrites. So this is of no use. So this has to be figure. So our logic is right, but something is missing. Let's try to see once again what we did. So the span is defined. 2. This is working fine. I think It is -1 to 2 only, right? Okay, reshape. -1 to 2, -1 to 2. That is okay. So let me just see what is the range of this, because if the range is not matching, then maybe we have some issue. Just this. I'll run this once again. It's plotting the same, right? I plot it. Yeah, see it is -1 to 2 both sides. Always -1 to +2. -1 to +2 on x-axis, -1 to +2 on even the y-axis. So it's correct. So whatever we are defining is right. -1 to 2. Everything looks fine. Okay, let me go back and check. Did I do anything, any change there? No. Figure, even P2 reshape, this, length of span. Okay, it doesn't matter. Colors now we define, so you don't have to define a color map, right? Previously we simply called a color map, right? Now it is not required. Okay, because you defined your own colors now. That's not required. View 2 is same thing, right? Pretty much similar. Should work. Mm, why did I have to call a hold down, I guess. Yeah, I called a hold down. That's fine. Everything will be plotted over this. Figure 1. Everything you plotted, or maybe the hold on. No, this should not matter actually. And should not actually matter. Still, let's see. This is not required by default. Doesn't make sense. Okay, fine. I'll try to solve that issue. I'll try to resolve it. If I'm able to, I'll definitely let you know. Okay, but our main idea was to know that how the machine is going to generate four different generate the classifiers which classify four classes. Okay, only some plotting issue, but no issue with the machine learning. Machine is still able to generate four classes using four, and it is able to show you four different colors corresponding to each of the class. How you can justify that? You can see you are using one first class, second class, whatever you learned for third class, and whatever you learned for the fourth class. We are using the four different classes the machine which the machine has learned. See the name of the variable predicted output. Whatever machine has predicted for class 1, we are giving some color. For class 2, different color. Class 3, different. Class 4, different color. So definitely we are able to see that yes, wherever you had the four different data points, you can visualize. That is coming now. Okay, only the points are not visible. I think some minor issue with my code. I'll definitely try to rectify. I don't want to waste time. Okay, right? So that's how you can see that all the points, right, which are inside this region, the region is actually, it's a straight line coming till here, then actually a curve moving to this side. You see, it's a non-linear curve, right? Similarly, there is another non-linear curve that is actually in for this region, and one straight line which is straightforwardly moving like this. You can see that it ultimately generated three curves, right, to separate four classes, right? So we can actually take like there are two curves only, not four curves, because one curve is minus 0.5 till 0. At 0 it is going to a high value. At the same time, at 0 it has a very small value, and then comes to this. This is the same curve. Okay, the two non-linear curves which we see here, it's a single curve. You can give one equation to that. That is curve number 1, and curve number 2 is a straight line. Okay, vertically moving down. That's a straight line. So two curves have been generated by our multi-layer perceptron to classify these four classes, right? Which was our intention, and we are succeeded in that.